Okay, so we're going to be having an introduction to DevOps. So what is DevOps? I'm sure so many of you have had. Somebody asked me one day and said, okay, so this thing you people call DevOps, DevOps, what is all this one? What is your place in the software development industry? All right, so I'm going to be doing a bit of a breakdown of what DevOps is. And I'm sure by the end of today, when somebody asks you what DevOps is, you should be able to answer the person and tell the person exactly what DevOps is and what a DevOps engineer does. All right, so I'm going to be sharing, I'm going to be moving between screens, between pages so that I tend to, all right, so somebody's hand is up. I think it's too early for us to have your hands up in the class right now. We're just beginning. So patience, what's the problem? Okay, so let's go further. Okay, so I believe you can still hear me. Please confirm you can still hear me and you can see my screen.
Yes, sir.
Yes, we can hear
Yes,
you.
sir.
We can see
We can hear
you.
you.
Okay, so currently the screen I seem to be
Yes, sir. Yes,
sharing
sir.
is the paint. Can you see my paint?
Yes, sir.
Yes, sir.
Yes,
We
sir.
can
Yes, we
see.
can see. We can see.
All right,
Yes,
so
sir.
Yes, sir.
okay, so
Yes, sir.
all right, thank you so much for your feedbacks. Okay, so let's go further. All right, so what we're talking about is DevOps, right? So what exactly is DevOps? What exactly is DevOps? So DevOps is just a combination of two words, development and operations. So that's why we have it as dev and ops. So development, operation is what DevOps is. And so what exactly is development and operation in the tech industry? So let's talk about it now. So I'm going to be using an illustration so you guys can have a better understanding of what DevOps is. So I said DevOps is just a combination of what? Two words, which is development and what? Operations. So that's what DevOps is. Now, somebody will say, okay, so development and operation. So what's this all about? So DevOps is not actually a technology. DevOps is a culture because it's not uh, a place where you just go and begin to click mouse buttons and then things begin to happen and all of that. No, it's not something you do using just one tool that you just come, okay, yes, this is what I want to do and all of that. No, it involves using several tools. You use several tools in order to achieve what you need to do. And so it begins from when you are building a code, it begins from when you are pulling a code from a repository. Then it gets to where you are packaging the code, where you are deploying the code, and then all of that. Sorry, excuse me. Okay, so like I said, when you come to this class, always mute your mic to avoid distractions. Some of these distractions they tend to slow us down. Okay, so I said DevOps. DevOps is not a technology. It is a culture. Because why? It involves you using several tools. So you can begin by using, we have where we use the cloud platforms. We have where we have to build containers. We have where we have to divide an application into microservices. So there are ways you do all of that. And then it gets to where you also have to begin to do monitoring. You set alarms and all of these. When your container fails, you get a notification. And so most of all of this, you use several tools to do that. And so that is why DevOps is not a technology, it is a culture. And so when an aspect of DevOps works for one of of your application, it doesn't mean that the same is going to work for another. Sorry, I think we need to listen to instruction. Who are the people raising their hands? Please drop your hands. If you have questions, note them down. You're distracting our class. So please, I would like us to adhere to very simple instructions. No interruption while the class is going on. You can ask your questions when the opportunity comes. So please, thank you for obeying the instruction. All right, so let's continue. Now, so I'm going to give you a simple scenario so that you would understand what DevOps really is and how it works. Now, you as a DevOps engineer, you don't work alone. You have other people you work with. Basically, you are not involved in writing of codes. The programmers or the developers are the ones that write the code. You as a DevOps engineer, you have your own role. Now, so we're going to be talking about what the roles of the developers are and what your role as a DevOps engineer is. And so please, I want you to follow me as I use a scenario to explain this. And so I use the paint so that when I do some of these graphical explanations, you can remember easily. So now I'm going to be doing this. So I have a client, right? So let me quickly bring out my client. Okay, so I have a client and he wants actually to develop an e-commerce website, right? So this is our client. What does he want to do? He wants to develop an e-commerce platform. Okay, so our client wants to develop an e-commerce platform. And so he comes to a company that deals in development and he tells them, okay, so this is what I want to do. I want to develop an e-commerce platform. Your client doesn't have the technical know-how. All the person has is business idea. And he comes, he doesn't know anything about programming. He doesn't know anything about development and all of that. So he comes and he tells you, okay, so I have my requirements, the e-commerce website. I want it to be something like maybe eBay, right? So it's going to have the marketplace. It's going to have where users come, they sign up, they make purchases. So it's going to have a database where you have your client information. It has their login details securely kept. It has their maybe card details securely kept also, because all of those things have to be secure. And so your client comes and is asking you, okay, so please, can you help me develop this? And then so you get all of the requirements from the client. What's the first step to do? Do you just begin to write the code? No, you don't start writing the code. You have to get the requirements. After you get all of the requirements, you have to go into design. Now, when you go into design, before you begin to write the code, development begins. So your client has come to you. I want an e-commerce platform. So develop an e-commerce platform for me. Now, there are several processes that occur during all of this. Basically, I'm not going to be talking about what the project managers do. I'm just going to be talking about what the developers do and what the operations do. All right, so the project manager has gotten the project. They have developed the product, sat down and had a meeting with the engineers, with the product team, and then they came up with a design. And everybody has his task. Now the developers have been given a task. So let us continue with our analogy. I'm going to pick this guy right here, and I'm going to drop him here. All right, so I have this developer. I have another one. and I have a third one. So in a company where you do development, you will have several people working together, several developers working together, everybody working on a specific aspect of the code. Okay, so it's not just going to be one developer. So like somebody might be working on the sign in, somebody might be working on the sign up, somebody might be working on the landing page. Every developer has a task assigned to them. And so they write the code. So now this is now what our development team. This is our development team. So what they do is they write the code. Basically, that's what they do. Now, how do they write this code? They write these codes on their local machines. And on their local machines, they begin to they run unit tests and make sure that the code works well so that they know that when they merge, it doesn't break. So your development team, they are here. What are their tasks as development team? So let's define their roles right now. So what your development team does is, number one, they don't just start writing the code. They have to understand the requirements. Understand the requirements of the clients. So what does the client want? How does he want the platform, right? And then after they understand the requirements, what's the next thing they do? They begin to develop. They develop the program or the app. All right, so after they develop, they actually they test the program. So as a programmer or as a developer, you don't just write the code and just begin to send the code and say, I'm done. You write the code. After you write the code, you run a test. And so when you run that test, it is called a unit test. And you run that test first on your local machine. And then when you have a central repository, you push the code and then you test the code also on your central repository. So on your central repository, that means every developer has sent in their code. And so after they have sent in their code, then they will merge the code and then test the whole code. So if anything breaks, they go back and run the tests. And so after they run the tests, if everything is fine, they send it back to the repository. So the next thing the developer does is they keep the code in the repository. All right, so these are the basic things the developers do in. So once the client has told you this is it, and the project manager has distributed everybody's task, right? Developers understand the requirements. Okay, so the part of the requirement is what programming language are we going to be using? Are we going to be using Python? Are we going to be using JavaScript? Are we going to be using Node.js, C#, C++, or what language are we using? So they have to understand that requirement. After that, they begin to develop the program. After they develop the program, they test the program. After they test the program, they keep the code in a central repository for further processes to take place. Now, our development team has done all of this. What's the next thing? So do they just pick up the code now and then send it back to the project manager and say, give it to the client? We're done. No, they don't do that. The client has no idea of what the code is. He doesn't know how to run the code. And so if you give the client this code, it's useless to the client because he has no idea. All the client knows how to do is, oh, I have the business idea. I'm a business person. And so if you give me this code, I don't know what to do with it. Okay, so what now happens is the next phase in development. So after this process has been done, the next thing that happens is what we're going to be talking about. So I am going to be picking this guys again. All right, so we have another team. All right, so now we have a new team. And who are this team? These are the team that will come up after your development team has finished their work. And they are called IT operations team. Now, in the IT operation team, that's where the DevOps engineer falls, because they are the ones that make sure that the code that the developer has written is not just given to the client who doesn't have an idea of what to do with the code. So they make sure that when you go to Facebook, they make sure that you see Facebook as it is. When you go to Jumia, you see Jumia as it is. So if we give you the raw code, you will not know what they look like. They are just designs. But because of the operations team, you are able to actually see the landing page of Facebook. You're able to log into Facebook and do all of this. Now, so let's talk about the roles of the operations, the IT operations team. So what do they do? Now, after codes have been built and everything has been tested by the developers, the operation teams, they set up virtual machines. So virtual machines are machines that are in the cloud or in isolated facilities. So if I'm to set up a virtual machine on my laptop that is going to host a code, it must be in an isolated place. So my laptop must not be carried to places. It must be in one particular location where there is no power interruption, right? Where there is no outage of network, where everything it's just there, isolated. Where when there's disaster, it's not affected. Now, so what they do is they set up virtual machines. I'm not going to be talking in depth about virtual machines until we get to our when we begin to talk about DevOps proper. That's when we're going to talk about virtual machines. But just know that virtual machines are machines that are set up either in the cloud or in an isolated place. So a laptop is not a virtual machine. Your system is not a virtual machine. You set up a virtual machine on your system. It's known as a server that is running on another machine. So that's what virtual machines are. And so after they set up all of the virtual machines, they begin to set up. So they also set up servers. So inside my virtual machine, I can either choose whether this is going to be a front end or a back end. So if it's going to be a front end, it's a server. If it's going to be a back end, I'm setting it up as a server. If it's going to be a database, I'm also setting it up as a server. So they set up virtual machines, they set up servers. They also will set up databases. They set up databases. Then after they set up all of these guys, they will begin to take code from repository. After they take code from repository, sorry, excuse me 1 minute. Let me quickly do something. All right, so let's continue. All right, so after they take the code, right, they build the code, and package the code. After they package the code, they will deploy. And then finally, all right, so let me quickly explain what I just wrote. So the role of an IT operations team involves setting up virtual machines, right? A set of servers, a set of databases. So a platform that is an e-commerce platform would have to have a database. It has to have a front end. It has to have a back end. And so, sorry, excuse me for 1 minute. All right, so as I was saying, so they set up servers, so you can have a front end, you can have a back end, you can have your databases. And so after they set up all of these servers, they will take the code that the developer has kept in the repository. After they take that code, they run a test. After running the test, they will now build the code. They will now package the code. After packaging the code, they will now deploy the code into the servers. So where after deployment of code into server, that's when you begin to see all of the platform, the Facebook, the Gmail, the Yahoo Mail, and the rest of them that you use. It's after the code has been deployed into servers that you see that. So it is only then that you can now deliver the project to the client. So in DevOps, the operations do not work alone. They work with the developers. And so that is why it is called DevOps. Now, in setting up all of this, guys, these virtual machines, the servers, there are several tools that are used. And so because of these several tools that are used, that is why DevOps is a culture, not a technology. It requires you to write certain scripts. It requires you to build certain containers. It requires you to split codes into microservices. And so you don't just split them by clicking mouse buttons. You do that by following several other procedures, using several other tools. Some of those tools can involve your we have you use the Git, the GitHub, you begin to use the cloud services like AWS, GCP, Azure, and the rest of them. You have other monitoring tools like Grafana, Prometheus, and the rest. And then we have, when you need to build container, you work with Docker. When you need to orchestrate those containers so they can talk to each other, you have Kubernetes and the rest of them. Several other tools like that. So that is why DevOps is not a technology, but a culture. So now, having said this, you have done this. What's the next thing? You are going to deliver your project to the client. And so these two guys work hand in hand. And so they are now called so the whole process is known as DevOps, development and operations. So after all of this has been done and achieved, then you can now deliver the project to the client as a completely packaged product. So the person who has a product can begin to do his marketing, have clients on his platform. It's not the role of the development and the operation team to get clients for the e-commerce platform. Theirs is just to develop, package, and deliver the code or the product to the clients that's giving them the job. And so that is just a simple illustration of what DevOps is. I have just taken a little time to just, in a nutshell, summarize what you do as a DevOps engineer. But believe you me, when you begin to do some of these processes, it's not as I have just used like maybe 15 minutes to explain to you. Sometimes it takes days, sometimes it takes weeks when you begin to troubleshoot, because maybe you are trying to deploy and then the container you are trying to deploy is failing to deploy. Sometimes when you are building, you might begin to have dependency issues. And so when you have all of those issues, you are not able to continue. And so you have to troubleshoot, find why all of these dependencies are like that, fix the dependency trouble, and then continue. Sometimes when developers merge code, they begin to experience merge conflicts and stuff like that. So that is why DevOps is not just a technology, it is a culture. It is a culture. And so, having said this, we will continue. And so, now, so what are the prerequisites for this course? We need to have a basic background of Linux and shell scripting. So I'm going to be taking us on basics of Linux and shell scripting. Yes, we will need to have a basic knowledge of at least one programming language. At beginner's level, just have an understanding so that when you are troubleshooting and you see an error, you are able to point to the developer, okay, this is what I have noticed. Please, can you look into this and let me know? Because at point of deployment, of course, you are going to have some of these issues. So you need to have a basic understanding, basic knowledge of at least one programming language. So at your leisure time, for those of us that are going to be studying with me or taking the DevOps course, I would encourage us to begin to take a bit of time to learn at least a programming language. But it doesn't stop you from taking the DevOps course. So, yes, you're going to have a good knowledge of at least one cloud platform. So these are some of the cloud platforms. Well, for this course, we're going to be talking about AWS. I'm going to be introducing us into Amazon Web Services. And then anyone who is passionate to kickstart their DevOps engineering career, those are the prerequisites for this course. And so please, you should make sure you attend class regularly, because whatever is being taught is going to be a continuation of what has been taught previously. And so if you don't have a background of what has been taught previously, you would have issues understanding other parts. All right, so having said this, let's continue. So for this course, this is our course outline. That's for those taking DevOps. We're going to be treating introduction to Linux and shell scripting. This one is going to be for the generalization. So everybody is going to learn, because as a developer, if you are given a system that uses a Linux operating system, how do you begin to navigate it? Or when you are working with a machine that doesn't have a user interface, graphics user interface, where you have to go and click mouse and all of this, how do you begin to work with command line? And so that is why we're going to introduce you to Linux and shell scripting. We're also going to be talking about an introduction to cloud computing. So that's where we're going to be talking about Amazon Web Service as a cloud platform. We're going to also talk about introduction to the DevOps world. So that's where we're going to be talking about a few of the DevOps tools you're going to be using as a DevOps engineer. So yes, and then, okay, so this is a DevOps tool. The introduction is where we're going to have scenario questions, and then we're going to talk about those scenario questions, and then you need to know how to design all of those things and begin to use the DevOps tools to do all of that. All right, so, and then finally, we're going to do some hands-on experiences. We're going to have some real-time projects, and we're going to do all of that. So I'm sure with this, you should be excited to want to learn DevOps. All right, so having said this, let's go further. Let's talk about Module 1, Introduction to Linux and Shell Scripting. So basically for this, we're going to be talking about what operating system is. And we're going to talk about the types of operating systems. We're going to talk about the Linux operating system. We'll go ahead and talk about a brief history of how Linux came about, or who started it, and what was the purpose for all of that. So we're going to talk about a brief history. Then we'll talk about the various Linux distributions. There are several Linux distributions, and so we're going to talk about them. And then we'll talk about why Linux. So why do developers or why do companies choose to use Linux? Why don't they use Windows? Why are they using Linux? And so we're going to talk about all of that. Yes, and then we're going to talk about ways to install Linux, or ways to install and use Linux on your operating system. Then finally, we're going to talk about shell scripting. Finally, we'll talk about shell scripting. All right, so let's go further. So let's talk about operating system. Okay, so what is an operating system? Can I have one or two persons? So if you want to answer, please raise your hand and I give you permission. So what is an operating system? What is an operating system? What is an operating system? Let's make the class interactive. All right, so Luis. Yes, let's have Luis go first. What is an operating system?
All right. An operating system is a software that manages computer hardware and the resources provided in the computer.
Okay, thank you so much for that. Thank you. Yes, I have Israel Patience. Israel Patience, can you speak?
An operating system is a program that, after being initially loaded into computer by a boss program, manage all of the other application program in a computer.
Okay, wow. That's amazing. All right, so thank you so much, guys, for this insights. I'm happy that we have ladies talking in this cohort. In the last cohort, we had to be calling ladies and saying, you are not speaking. So I'm impressed, and all your answers are very correct. Yes, so we're gonna go further. Sorry, guys, I have gotten two people that have answered. So subsequently, when I ask questions, I'm gonna give opportunities for us to also answer. All right, so let's go further. So operating system is a software which is used to compute memory, network operations for the application running the OS. So if I have like my laptop now and I don't have this software on it, I will not be able to compute the memory. I will not be able to access my network like I'm doing. I'll not be able to run the Zoom application that I'm using right now. And so the operating system makes it possible for us to be able to do that. It makes it possible for us to, when we have a visual representation of our document, we can print it. We can also interact with other external devices. It is the operating system that makes it possible for us to be able to do all of that. And so, sorry guys, can you drop your hands? Can you guys drop your hands, please? All right, so I seem to be having other people's hands still raised. Can you lower your hands? All right, so let's go further. Okay, so now the operating system is composed of many programs, and so it also allows, or it always runs behind a graphics user interface, where the graphics user interface is composed of a layer on top of it. So your operating system will always have a graphics user interface, and basically you can interact with the operating system through your graphics user interface and your command line interface. And so talking about the graphics user interface, when you boot your Windows operating system, the graphics user interface is why you are able to see your desktop and all of the icons that are on your desktop. Your graphics user interface is why you're able to go and click your start menu option and you're able to go and access your documents. But using your command line interface, you don't see all of those desktop. You can actually access your desktop, but you will not be able to see the folders or the icon for, maybe, let's say, for Google Chrome, or the icon for Zoom. You'll be able to list all of those, but you will not be able to see them. And so that is the difference between your graphics user interface and your command line utilities. So basically, operating systems have a graphics user interface and a command line utility. And so even in your Linux operating system, we have the graphics user interface and your command line utilities. But Linux has made it very interesting that it got to a point where you can actually work without seeing the graphics user interface. And so you just install a server, and all you can see is, you just see the command line interface. Like Windows used to have it when they used to operate DOS. You don't see anything. All you need to do is just come and type in command line, and then you run it, and then they begin to work. So you don't come and just double click Microsoft and begin to type. No, you use a command line to do all of that. But Windows subsequently began to develop themselves, and so they came up with the graphics user interface. And so all of those DOS utilities now are being used for servers. And so the reason why we are going to teach you Linux is because when you begin to work in an organization where they don't use graphics user interface, so how do you do it? How do you navigate between folders? How do you make corrections? How do you write scripts and all of that? How do you send commands and they execute? And that is why we're going to be teaching you Linux operating system. So basically, I'm not going to be dwelling on the graphics user interface for this Linux operating system. I'm going to be dwelling more on the command line interface. Because even in the cloud, when we run servers, we hardly use the graphics user interface when we are running our servers. We use our command line interface to interact with our servers in the cloud. So, having said this, let's go further. Still talking about operating system. So, all right, so can I have two people tell me the types of operating systems you know? Just two persons, please. Raise your hand. All right. Olua Damilare and Emmanuel, you can go ahead. Others, please. Yes, Damilare, what are the operating systems you know? Or let's say, just give me one. So the four people that have, these four people I can see on my screen, you can give me one operating system you know each. All right, so Damilare, you can go ahead.
Hello, good morning, sir.
Yes, good morning.
Ubuntu.
All right. Okay, thank you. Yeah, Emmanuel.
Sir, Microsoft. Good morning, sir.
Okay, good morning. Paul.
Linux, sir.
Sorry? Sorry, I didn't hear you, Emmanuel.
Linux.
Oh, Paul. Okay, Linux. All right. All right, so Adaize.
Android.
Okay, thank you.
Yes.
Any other operating system that we have not mentioned?
Yes,
Mac
sir.
OS.
Okay,
Apple.
Mac OS. All right.
iOS.
Okay, thank you so much, guys, for all of this. All of those operating systems are correct. All right, so we have the Android, which is the one that runs on your phone, right? We have some other PCs that actually run Android also, but they are not common. Then also we have the Mac OS and their iOS. The iOS is for their phone, and then the Mac OS is for their laptops. We also have Linux. Now, somebody mentioned Ubuntu. Ubuntu is actually a distribution of Linux. So it's part of Linux operating system. And so when we go to talk about the distributions, we are going to see all of that. We also have the Windows, which most of us are familiar with, and most of us run Windows on our laptops. Yes, and so several other ones. We have several other ones. We have the Mozilla Firefox OS. We have several other OS. So you can go and do all of this research on your own, but these are the common ones that we use almost on a daily basis. Some of us will use Windows, some of us use Linux, some use Mac. Almost every of us uses Android on our phone. And so those are the types of operating systems we have. And so I'm sure we will not struggle to answer when somebody asks us the types of operating systems. Okay, so what is Linux operating system? So we're entering into Linux properly right now. So what is Linux operating system? I'm sure so many of us have heard about Linux operating system, and then we have been wondering what Linux is. And some of us will say, oh, the name sounds sweet. So what is Linux operating system? Okay, so Linux is a free and open source operating system that was created by Linus Torvalds in 1991. So the creator of the Linux operating system is Linus Torvalds, and he created this in 1991. He had an experience, and so he didn't like the experience he had, and so that was why he decided, okay, he was going to create his own operating system. And so after he created the operating system, in order for other people not to have similar experience he had, he decided to make the operating system free and open source so that anybody can go and download it and use it. And so now this operating system is based on a Unix operating system. So there used to be a Unix operating system. Linus Torvalds wanted to do a project, and so when he wanted to use an operating system, they told him he had to pay. And so because he was told he had to pay, he didn't like that idea. He felt anybody should be able to access this. So he decided to pick the Unix operating system, part of the Unix operating system, to use and develop Linux. And so that was how Linux came about. And so the operating system became one of the most popular operating systems for servers. So most servers run on Linux, embedded systems, and desktops. And so organizations like banks prefer to use Linux for their servers. MTN and all of these network companies prefer to use Linux as their servers. And the reason why they do that is because it is stable, it is secure, and it is flexible. So using Linux is very secure. The fact that it's open source doesn't mean that somebody can easily come and hack your application. No, it is very secure. It is very stable, and it is very, very flexible. So that's why people prefer to use Linux operating system for their servers. All right, so, and then it doesn't belong to any company. Linux doesn't belong to any company, just like Microsoft belongs to Windows, right? Mac OS belongs to Apple. Linux does not belong to any company. It is a free and open source. You can also add to the development of Linux. Please, if you have a question, note it down. You will ask your question later. And so, but over time, people began to also pick Linux, and they started to develop and add their own utilities, add their own flavors. And so they started having several other distributions, and some started to charge money. And so it depends on what you want to do. So you choose whether you want to buy or you want to use the free version of the Linux operating system. All right, so now the Linux operating system has both the graphics user interface and the command line utility. So if I install Ubuntu on my, sorry, who is the person constantly unmuting themselves? You are distracting us. All right, so if I install Ubuntu on my local machine, I'll be able to access both the graphics user interface. When you install Ubuntu, which is one of the distributions of Linux on your local machine, you will also have the graphics user interface and the command line interface utility. And so, but there are parts where you can just install only the command line utility without having to install the whole package or the graphics user interface. So that's where we use the servers, where you don't see, the only thing you see is your command line interface, and you don't see your desktop, you don't see the content of your folder. You can only see that only by using commands to view all of that. And so for some of us, we might have to install the graphics user, the Ubuntu on our laptops, or we would have to install virtual machines and then install the Linux operating system on it. Okay, so let's go further. I believe you can still see my screen.
Yes, sir.
Yes, sir.
Okay, all right, so thank you. All right, so let's talk about, when I was talking about the Linux operating system, I said it is an open source, right? Now let's talk about what open source, the difference between open source and closed source is. A closed source does not allow a user to improve it. So Microsoft, it doesn't allow you to improve. You only pay and then you begin to use, right? But for an open source, it allows for contributions. Others can come, I have an idea, and so I can just come and make contributions to the current development and improve it. And so, and then using the, sorry, 1 minute. All right, so yes, so for closed source, it doesn't allow users to improve. Once it has been developed, the organization manages it, and so it stops any other person from being able to make an improvement. But open source allows for collaboration. And then for a closed source, you cannot be distributed freely. So you know that Microsoft, you have to pay to use. Some of other Linux distributions you also have to pay to use. But for most of these Linux distributions like Ubuntu, Kubuntu, and the rest of them, they are free. You can just go to the website and go and download and install on your machine, and then you use. But for Windows, you have to pay. For Mac, you have to pay. So those ones are considered as closed source. They are considered as closed source. Okay, so let's talk about, okay, so the history and evolution of Linux. So how did Linux come about? So Linux has its roots in the Unix operating system. So like I said, Linus Torvalds decided to pick a portion of the Unix operating system, and so he made a different change in the kernels, and then he came up with his own operating system called Linux. And so the Linux, the L-I-N came from his name, Linus, and then the rest of it came from the Unix. So in 1991, Linus Torvalds, a Finnish student, started developing Linux as a personal project. And so the first version, Linux 0.01, was released in September 1991. And since then, Linux has evolved significantly. So there have been several contributions, several other people came in, and so they improved it. And so it is what it is today. So today, Linux operating system powers a large percentage of world servers. Most of the servers you see running in the cloud, they run on Linux operating system. And so you can see that Amazon can pick up a Linux operating system, customize it for their own personal use, and then they use it. And so everybody started developing their operating systems like that. And so that's why we have several distributions of the Linux operating system. And so majority of our servers run on Linux operating system. And so for those of us that are going to be taking the DevOps class, when we begin to talk about AWS, you're going to see that most of the operating systems the servers run on are actually Linux-based operating systems. And so let's now talk about the distributions of Linux. So what is a Linux distribution? It's the Linux distribution, often called a distros, is a version of Linux operating system that includes the Linux kernel, supporting utilities and software packages. So we have several distributions available, and each of them is tailored to a specific need. So we have the ones, so for those that are into ethical hacking, there's a specific Linux operating system you will use. For those that are just for hosting cloud servers, there are specific Linux operating systems. So every of the developed Linux operating system is tailored to a specific need. It's tailored to a specific need. And so pardon me, guys, I might need to switch locations because it's about to get a bit noisy here. So just give me like 2 minutes to do that. All right, so let's go further. Okay, so like I said, every of this operating system is tailored to a specific need. So everybody came and said, okay, so I want to go into ethical hacking. And so, in ethical hacking, security is one of the major things that are being considered. So somebody decided, okay, so I'm going to now create my own distribution of Linux. And so that was how everybody now started. And so some other people came, picked it, they created their own distribution and called it Ubuntu. Another one came, picked it up, called it Kubuntu. Another one came and called it Kali Linux. Another one came, picked it, said theirs is SUSE, Red Hat. All of them started creating all of these distributions. And so now we have several distributions of Linux operating systems. But for our course, we're going to be using Ubuntu. We're going to be sticking to Ubuntu as the operating system distribution for this course. Okay, so still talking about the distribution. So some of the popular distributions include Ubuntu. Ubuntu is a user-friendly distribution, so it's popularly used for desktops and servers. So, and then we also have CentOS. CentOS is a stable and secure distribution it's often used for servers also. CentOS happens to be a free distribution also. So Ubuntu is also a free distribution. CentOS is also a free distribution. We have the Debian. It is known for its stability and a large repository of software. So there are several other distributions under Debian. And we also have the Fedora. It's a cutting-edge distribution that often includes latest features. Fedora, you have to pay to use Fedora. We also have the Arch Linux. It's a lightweight and flexible distribution for advanced users. We have the Red Hat, all of those other ones. So there are several of them. So in your leisure time, you can go and read about all of these distributions and then you have a proper understanding. So I will advise that whatever we are teaching you, you should also make efforts to improve yourselves. Make efforts to not just sit and just take everything. Go and also learn new things. There are recent updates, there are experiences others have, and so you can also go and learn from them. Okay, so some of the uses of Linux operating system are represented in the charts here. We use Linux operating system for web servers. We can install them on our laptops and our desktops. We have mobile devices that now run Linux OS. And even the Android operating system came out of Linux. Mac is a subsection of Linux. Now, in film production, they also prefer to use Linux operating system. Government organizations use Linux operating system because they have policies for security and all of that. So they choose to use Linux operating system because it is secure, it is stable, and it is flexible. So why do we use Linux? Why not Windows? Why not Mac? Why not other operating system? Why Linux? One of the major reasons is because Linux is open source. You don't have to pay to use it. It is free. You can just go to the website, download it, and then install it and go ahead and use it. And then all of the softwares or all of the updates that you need, you get them from a centralized location by running a few commands, and then you get all of these updates. Linux is reliable, not like Windows. You are just using Windows and then suddenly you just see the blue screen of death. It just crashes. I think some couple of weeks, this blue screen of death happened, and then organization lost so much money because they couldn't access their Microsoft accounts and all of that. And so organizations prefer to use Linux because it is reliable. It is very stable. And then another reason is because of licensing costs. Linux has no accurate licensing fee. Unlike Apple, macOS, or Microsoft, you have to pay for licenses. So when you want to get a new operating system, you have to pay for license and all of that. And so, but with Linux, you can just download free and use it. You can even develop that one. If you want to customize your own, you can customize it and use it without paying. And so that's why people choose to use Linux. And then there is backward compatibility. Linux and many open source software tend to be frequently updated for functional and security patches. Unlike Windows, it's not every time Windows will be updating all of those security, but with Linux, they're always updating all of that. So you will not be afraid of whether somebody is going to hack you and all of that. And for those of you that know about the dark web, you know that you cannot use your Windows to go to the dark web. If you use Windows to go to dark web, your system is gone. Your information is gone. So most of the people that visit the dark web, they use the Linux operating system. They have a specific version of the specific distribution of Linux that they use. And so all of that. And then there are several other choices between almost infinite options, because there are several available distros, so you can test all of them. There are several configurations you can do. And so because of all of that, so people prefer to use Linux operating system. Okay, so let me take one more part before I begin to take questions, because it seems several of us have questions. And so I'll take, yes, so let me talk about how we can use Linux. So you can directly install Linux on your local machine. So instead of the Windows, you can just decide that, okay, I want just Linux on my local machine. And so you can directly install Linux on your local machine. All right, so you can directly install it on your local machine and use it. Then you can dual boot alongside another OS. So you can have Windows operating system alongside your Linux operating system. So when you are starting up your boot, you can choose whether you want to boot into Windows or you want to boot into Linux. So you can dual boot side by side. They will share hard drive. And then you can also use a virtual machine. So you can install the Oracle VirtualBox. And then in the Oracle VirtualBox, you can install your Linux operating system. And also, you can also try the OS without installing. So they give you that opportunity to try their operating system without installing it. So all you have to do is you have to make a bootable disk. either using your DVD drive or you use a joystick of your flash drive. And so instead of installing, they have an option, try. And so you will try the operating system. But the problem with trying it is whatever change, whatever updates you make doesn't remain. So each time you need to use it, you will have to do your previous updates. So assuming I installed git bash on my the one I was trying, as soon as I shut it down, the next time I come to use it, I'm not going to find the git bash. I have to install it again. So these are ways you can use your Linux operating system. So for those of you that have strong laptops, I will encourage you to either dual boot or use a virtual machine to install Ubuntu. And then there's another option. You can use the WSL for Linux. So for this course, I'm going to be using WSL, and I'm going to teach us how to install WSL to our Windows machine. WSL is it just gives you a Linux environment. It gives you the command line utility of Linux, and then you will use. If you're not able to use any of this, there is still an option. You can install, you can download Git and install Git on your local machine. And so when you add it to your local machine, it gives you the opportunity to be able to use some of the commands for Linux. Now, you must also take note that the commands you run on Linux operating system don't work on Windows. Commands for Windows command prompts are different from the ones you run on your Ubuntu machine. So when you are navigating from one folder and using a command on Linux, the navigation might be different from that of Windows. So you must take note of that. Okay, so this is where we're gonna end today. When we when we meet next time, we're gonna go deeper. We're gonna dive deeper into the basic Linux commands. And so that's where I'm gonna start talking about navigation between folders, creating files, editing files, copying files, and several other application of the command line utilities. So we're gonna stop right here. So if you have questions, let's begin to raise our hands. Okay, so we have Janet David. Go ahead and ask your question. Please, as soon as you finish asking your question, you drop your hand so I can know the next person. Okay, so yes, Janet David, let's have you. Janet David, can you ask your question, please?
Okay, there are some questions on Telegram. Sorry, let me just read them. Sorry.
Okay, ma'am.
Some questions on Telegram. Are they really questions? Okay, so somebody said, so who has the right to grant the improvements of Linux OS? And please, what particular programming language will you have to learn for DevOps?
Okay. Well, for who grants permission to edit, there's nobody that grants permission. That is why it is called an open source. It's an open source distribution, so they have a back end where you can always go in and make your improvements. And so you don't need to go and seek permission from anybody before you use it. So that's why they made it open source, free and open source. And then for DevOps, you need to learn DevOps the basic programming languages, or the one you need to have an idea of, Python is one of them. So you can go for Python. You can then another programming language is Go language, Golang. And then you should also have an idea of Node.js. So if you have an idea of any of those programming languages, you are fine. You are good to go. But you can also learn other programming languages. But for DevOps specifically, Python and Go language are very important. Okay, so I guess that answers that question. Can we have the next person? Let's be snappy because of our time.
Okay, somebody is asking, I think on Telegram as well. Please come again on the difference between GUI and command line utility.
Okay, graphics user interface.
Okay.
It's what you see, and then you can use your mouse to navigate, to click. You use your mouse to do almost everything. So that's how the graphics user interface works. Command line interface, you can only see where you type in commands. You don't use your mouse. You use your keyboard to type in commands and to execute commands. So that is the difference between the two. Okay, so next question.
Okay, that's all on Telegram. Thank you.
Okay, so people on Zoom.
Can I ask my own?
Go
Their
ahead,
hands were
please.
raised.
Okay, my question is three like this. Number one is that you said when the project manager has distributed the work, and then the DevOps people will go and then share the work and start working, the dev will do his own before the op. Where is the place of the other ones, of the programmer, of the back end, front end, all those data science and all that? Because in what you explain, it is dev man that developed the package, and then is the dev man that also interface it to the server and upload it and get it running. So where is that part? Second question is, what is dark web? What is dark web? Then the last question I have is, you said the Linux is secure. Does it mean it cannot be hacked? It cannot have an interference? Is it safe like that, that even while you are using it, you don't need any antivirus or anything like that?
Okay, so I'm only going to answer two of your questions. The dark web was just me making a reference. It has nothing to do with the course. If you want to know about dark web, you can go and Google it, and then but don't visit the dark web, please. All right, so the first question you asked, the place of the programmer. The programmer is known as a developer. So all of the data scientists and the rest of them that you have mentioned, they are all part of the developers. Because the programmer is the one that writes the code. So that was why I said you understand the requirements, you understand what programming language you are going to use before you start writing the program. So a programmer is part of the development team. And then your other question is about Linux. Yes, when you use Linux, you don't need an antivirus, because virus doesn't have effects on Linux operating system, not like Windows. And so that is part of the security we're talking about. And then if I install my Linux and I set up my Linux, if I don't compromise my operating system, you cannot hack it. Except I choose to let you hack it, you cannot hack it. And even if you hack it, I will know. So Linux is that secure. So that's why most organizations choose to use Linux operating system. Before you even hack it, you will know what you will learn, but it is very secure. All right, so I guess that answers that question. Can we have the next person?
Hello, good afternoon, sir.
Yes, good afternoon.
Yeah, please, I just have two questions to ask, sir.
Okay.
The first one I want to ask is, can Microsoft Office Suite run on Linux? And the second question I want to ask is that, can I like uninstall all operating system on my own system and install Linux, and it will serve all the purpose of maybe if I'm into graphic design and other things, it will also serve the purpose.
Okay, so first question, Microsoft's Office Suite doesn't work on Linux. They have their own Office package that you can use. And so when you use it, you can still open it using Microsoft. And then, yes, you can use your Linux to serve, they have other graphics
Hello,
tools.
sir. What's the full meaning of WSL?
Sorry, I'm answering a question. All right, so you can, yes, you can use your Ubuntu for your graphics design. They have several design tools that you can use. One of those design tools is called GIMP. You can use GIMP for your design. And so if you don't want to use Windows, you can go ahead and use your Linux for your graphics, and it will serve. In fact, I think they have one of the best graphics interface. So yes, you can use it. All right, so yes, the next question, please.
Hello, sir.
Yes.
Hello, good afternoon, sir.
Yeah, good afternoon.
Yeah, you talk about open Linux and closed Linux, right? Yes, sir. I want to ask, sir, is Google Play Store an example of open Linux where you can have access to download and install?
Okay, sorry, I can't remember talking about. We don't have anything as open Linux and closed. We only have open source
Okay, yes.
and closed source.
Yes, sorry.
So whatever allows you to be able to make contribution and is free is considered open source. Whatever you cannot make contribution to and you have to pay is known as closed source. So like I gave an example, when you buy your Microsoft Windows, you are not able to make any changes to the operating system. In fact, if you mistakenly enter the heart of the operation system and you make a change, it will crash. But it's not the same with Linux. With Linux, you can go and customize it and use it. So Play Store is not considered as open source because it is owned by a company, and then sometimes you have to pay for the softwares. All right, so can we have the next question?
Hello. Yeah, this is Vivian. I want to ask, when you started the class, there's this environment you were using to illustrate what the juxtaposition between the developer team and the IT team. And secondly, the other question is, I want to know what's the difference between server and database. And the last question is, what is the difference between cloud computing and DevOps? That's my question, sir.
Okay, so the first one you asked was the environment I was using to illustrate. I was using Paint.
Oh, Paint.
Yes.
All right, sir.
I was using Paint to do my illustration instead of using the whiteboard. Whiteboard doesn't give me flexibility like that. And then the second question has to do with sorry, remind me again.
Yeah, the second question has to do with what's the difference between database and server.
Okay, yes, database is used for you use database to store information, They could be in tabular form, they could be related information, unrelated. So like if I give you a form and then I have people who filled their age, they filled their marital status and their maybe their names and all of that, you use a database to collect all of those information. Now a server is what is used to access the database. So now the Facebook that you're seeing is just a front end. The Facebook you're seeing is just a front end. There is a back end. There's a back end that makes a request. So when you try to log in on Facebook, it makes a request to a back end. The back end pulls your information from a database and then it sends your login details and then you're able to log in. So database keeps record information. The server could be a back end, could be a front end. They are the ones that make requests. And then they are the ones that allow you to be able to see the end product and make interaction with them. And then you said the third question, cloud computing and DevOps. Cloud computing, you can study cloud computing on its own. This deals with the study of cloud platforms and how to use them. But to be a DevOps engineer, cloud computing is one of the tools or the components of DevOps. So you must learn cloud computing to be able to work as a DevOps engineer. And then DevOps has several other tools apart from the cloud. Okay, so please, every other question, can we just make them snappy?
Okay, sir. Can you hear me, sir?
Yeah, I can hear you.
Okay, my question is how long will someone learn this DevOps before he can, he can be qualified to say he's a DevOps technician or whatever? How long? Is there any points at which you come before you can tell people that you can handle a project on DevOps and all of that? And then, sorry, I was trying also to get the difference between DevOps and cloud computing. I don't know whether it was from my own network. I didn't get that differences, sir.
Okay, so for DevOps,
Thank you, sir.
For DevOps, you never stop learning. It is a continuous process because several other tools are being developed to make the work easier. There are parts where you need to automate, so it takes a continuous learning. But for you to actually be a proper DevOps engineer, there are specific tools you must learn, and it takes a bit of time to learn that. So most of what we're going to be doing is exposing you to these tools, and then on your own, you can gather experience and you can do an in-depth study of all of those. So there are several other tools you will need to learn. And then for the cloud computing and the DevOps, the difference is cloud computing is part of the tools you learn for DevOps, but you can also learn cloud computing on its own. So you can be a cloud engineer. But for you to be a DevOps engineer, you must also learn cloud computing. I guess that answers that question. So the next question, please. We have 5 minutes to wrap up. So I might not be able to take all of the questions. Yes, I can hear you. Go ahead.
Okay, sir. Thank you. I want to ask that what could be the consequence of installing Linux on a Windows system? For example, some years back, I installed Linux on one system like that of mine. I lost the hard drive of that system. And of recent, my new system, I installed WSL on this system as well. So of recent, I am seeing this blue screen of death. So because of that, I quickly uninstalled the Linux on my system. What could be the consequence? Is it that there are settings I need to put in place that I didn't put in place that could result into this? And
Okay.
I also heard that you said you are using that WSL. So how do you do it, sir?
Okay, so well, installing Windows and Linux alongside has nothing to do with your blue screen of death. Blue screen of death comes when you don't maintain the security of your Windows operating system. Possibly a virus got into your system and then it's went directly and affected one of your Windows files, it will cause your system to misbehave. But installing Linux is not the reason why you have the blue screen of death. So your security, how you use your antivirus, and the kind of devices you connect to your system, what you download into your system matters. It has nothing to do with whether it because you install Linux. All right, so
My question, sir.
okay, go ahead.
Good afternoon, sir.
Good afternoon.
Please, I want to know whether we need networking and knowledge to be proficient in DevOps.
Well, networking is not really a priority because the cloud has taken care of that one. The only place where you need it is when you need to spin up servers, and then you need to know what you need to the architecture for how people are going to have interaction with your server, who accesses your server. That's when you begin to talk about networking. But it's not a priority for all of that. Just have a basic understanding of networking, basic, not an in-depth. Except if you want to be a cloud networking engineer. But for DevOps, just the basics is fine.
Okay, secondly, since automation is like a key in DevOps, when everything becomes automated, so what becomes the hope of a DevOps engineer in terms of
Is it not the DevOps engineer that is automating? Are there not times where the automation fails? Maybe because of dependencies? Of course, you will monitor your servers, you will monitor changes and all of that. So your place as a DevOps engineer cannot be replaced. You are the one that is making the automation. You are the one that is monitoring the automation.
All right.
Okay, so
Thank
next
you.
question quickly. We have 1 minute. The rest of you, I think you might need to type your questions and drop them in the general group. And then specify DevOps so that I will be able to answer them. Okay, so one last person.
Good afternoon, sir.
Good afternoon.
I want to know the specification needed for me to operate a Linux operating system
Okay.
on my PC.
Okay, your PC should have at least 8 gig RAM. Your processor speed should be at least 2.4 gigahertz. And then your hard drive should be at least up to 256 to be able to run Linux directly, not for virtual machine, directly on your local machine as your operating system. All right, so guys, please, the rest of you, type your questions and drop them in the general communication platform. I think there's a portion for question and answer there, so you can drop your questions there. So thank you so much for attending to this class.